Hello, this is video 36. It's going to be a brief video just going over a conceptual idea of what is a fictitious force. There are not going to be any problems associated with this video, just a conceptual idea. So let's start with this your turn here. A rider in an amusement park ride finds herself stuck to the wall after the floor has dropped away. Which diagram correctly shows the forces acting on her? So we need to pick the correct free body diagram. And hopefully you've been in one of these rides, so you know what sensation that she's feeling. You're spinning really quickly, the floor drops, and you just feel stuck to that wall as it's spinning. So the key is to be able to identify the forces here. So we know that she's not sliding up or down here because she's stuck to the wall. So for any downward force, there must be an upward force to oppose it so that she doesn't slide down. So that means that C and E are not good choices because there are no upward forces. And then we just have to figure out the other forces. Well, she's against a surface. A surface provides a normal force pointing away from the surface. So B does not have a normal force. So we're left to choose between A and D. So they both have an upward force. Choice A has a straight up force. Choice D has a diagonal force here. Well, if it were choice D, then what would this diagonal force be? Is there something that's pushing her at an angle? I can't think of any force that's pushing her that way. So that's not a good choice. So the correct answer is A. And now if we can identify these forces, this upward force that's preventing her from slipping is a static friction force. The force to the left is a normal force, downward force is the weight. The reason I really like this example is because if you've been in one of these, you've felt the sensation of being pressed in toward the wall. You felt this force here, but this force is not a real force, and that's the topic of this very brief video. This force that you feel that's not a real force is called a fictitious force. It arises because you're in motion. Another example of this is if you're in a car, right? So in this case, you're making a left turn here and you feel like you're pulled outward, but in reality we learned that there's a force that actually pulls the car inward to allow it to make that turn. So that fictitious force goes in the opposite direction as that real force. One last example is if you're in a car, and this is not a picture of a car, but it has a good visualization here. Let's pretend that this is you in a car and that there's a book on the dashboard and you're making this left turn here. What happens to that book? Well, by the time you've made the turn, by the time you're over here, that book has slid to the right? And the reason being is not because it felt this outward force. There is no outward force pulling that book outward. The reason that the book feels like it's going outward is because the book was actually just going straight. There was not enough friction on that dashboard. See if I can draw a little picture here. So there's the book that was right here. As you make that left turn, that book just ends up going straight. So when you're in the car right here, this is you in the car here, then it looks like the book slid to the right, but it just went straight. There was no outward force. There is no so-called centrifugal force. It's called centrifugal when the object is rotating. So the only force that there is when you're going in a circle is a centripetal force pointing toward the center. The only reason that you think there's an outward force called a centrifugal force, which is not a real force, is because you're in a rotating frame of reference. You're rotating, and Newton's laws of motions are not working correctly in your frame of reference. You have to look at it from an inertial frame of reference or from a rest position from the outside, and then you can see what's really happened, that there is no outward force. It is a fake force.